Okay, so here's the deal. Astronomers just found a mysterious object from the early universe using James Webb data. But wait, this isn't just another space discovery headline. This one actually changes how we understand cosmic evolution. Let me explain why this might be more important than you think. And you remember the first JWST images that broke the internet? Those deep field shots showing galaxies from when the universe was basically a toddler. But here's what they didn't tell you. Hidden in that data was something even the original teams missed. A gravitational arc so perfectly aligned it's like finding a needle in a cosmic haystack. And the kicker. It was discovered by a Costa Rican astrophysicist working independently. That fact alone tells you something huge about how science is changing. And gravitational lensing. Einstein's prediction about spacetime warping light isn't new. But what Gutierrez found takes this to another level. Imagine looking at a galaxy cluster and seeing light from 13 billion years ago bent into an arc. That's not just cool optics, it's a time machine. And this particular arc? It's brighter and more perfectly aligned than 99% of what's out there. Personally, I think this changes the game because it proves we've been missing stuff right under our noses. And what fascinates me most is the methodology. Gutierrez combed through 54 fields, checked 1,591 candidates, and only this one passed the test. Why? Because it defies 3 critical checks. Its shape is absurdly elongated, 6.5 to 1 ratio. It's brighter than anything similar at that distance, and get this, it didn't exist in any previous catalogs. That last part? That's what makes my spidey sense tingle. We're talking about a massive galaxy cluster that should have every object mapped, yet something major slipped through. And now here's where things get wild. The initial redshift measurement was wrong. Not slightly off, completely misleading. Automated systems thought it was at Z almost equal to 4.4, but proper analysis showed it's actually Z almost equal to 1.4. Wait, what does that mean? We are seeing it 9 billion years ago, not 13 billion. But hold on, that's still ancient. And the fact that computers got it wrong? This raises a huge question about how much we are missing because we rely too much on algorithms. And the really deep insight here. This discovery isn't about one galaxy. It's about what it represents. The Webb archive is basically a goldmine that's barely been touched. If one researcher can find this, imagine what else is hiding in the data. But there's a catch. We have to stop trusting automated systems completely. The photometry software failed here because it couldn't handle an extended source. How many other discoveries have we missed because our tools aren't evolved enough? Let's zoom out for a second. This has implications for how we understand galaxy formation. Finding a massive galaxy at Z almost equal to 1.4 that's been lensed perfectly. That suggests there might be more hidden galaxies in the early universe than we thought. What if our current models are incomplete because we are missing these magnified objects? This could mean the universe was forming structures faster than we believed possible. And the collaboration angle? That's the part that gives me hope. When Gutierrez reached out to the original team, they didn't get defensive, they helped. This is how science should work. Open data, collaborative verification, shared discovery. The fact that this process worked exactly as intended with JWST data might be more important than the galaxy itself. And so where does this leave us? Sitting on a massive realization. We are probably looking at the tip of the iceberg. Every new Webb image contains potentially dozens of undiscovered objects. But here's the thing. We need both human intuition and better tools to find them. This discovery proves that while technology is amazing, sometimes you need a fresh pair of eyes and some good old-fashioned persistence to find what everyone else missed. And what do you think? Could this change how we approach space discoveries? Drop your thoughts below. I'm curious to hear what this makes you wonder about the universe's biggest secrets.